Hi, my name is Carson Stromberg, and I'll be doing my final project on interstellar space travel. Interstellar space travel is something that has always fascinated me, but I never thought it would be possible within my lifetime, and it turns out I was wrong. There's a program out there called the Starshot program. It's funded by a Russian billionaire physicist named Yuri Milner, and their goal is to accomplish interstellar space travel and make it to Alpha Centauri. Alpha Centauri is the closest sun and planetary system to our solar system, and it contains the closest star to our solar system. The star in Alpha Centauri is very similar to the sun, and there is a planet that orbits the star that is very similar to Earth. This planet is within the habitable zone of the star, which means it's not too far, not too close. It's just right in the perfect area where potentially life could exist, and that is what the Starshot program wants to find out. How they're going to do it is they're going to use light sail travel. I have a picture of that right here. How light sail travel works is they will have lasers on Earth. Those lasers will shoot a beam into space, and that beam will hit this square cell. The cell, it's like a sailboat getting pushed by the wind. That's how this works, basically. As this laser pushes the cell into space, it'll go faster and faster until it reaches potentially 20% the speed of light. That's important because Alpha Centauri is 4.5 light years away from Earth, which is about 25 trillion miles. Using the fastest rocket fuel spaceship that we've ever invented, it would take about 120,000 years to get to Alpha Centauri. But with these light sails going 20% the speed of light, it only takes about 20 years, which is totally reasonable and possible. How these light cells work is they're going to, how this works, they're going to make a couple thousand of these light cells that are called nanocrafts. They're square, they're about 1 meter in diameter, and they're very, very thin. At the center of these nanocrafts, they're going to put a camera. They're going to shoot, a couple thousand of them into space towards Alpha Centauri, and once they reach Alpha Centauri, all of these cameras are going to be taking pictures and just send a stream of information back to Earth. The resolution on these cameras will be good enough in order to see oceans and continents if they exist on this planet. If there's oceans, that means there's water. If there's water, that means there's potentially life. Here's an analogy. If we were to take this picture from Earth using a camera, a regular camera from Earth, that camera would have to be roughly 300 kilometers in diameter, and that's not even physically possible. 300 kilometers is a big camera, and that's not going to happen. So in order to get pictures of Alpha Centauri and find out if there's water on this planet, we're going to use these nanocrafts. So hopefully, this project's going to take about 20 years, and then, it'll take 20 years once they finally launch these nanocrafts to get to Alpha Centauri, and then it takes about 5 years for the images to get back to Earth. So that's about 45 years from now. So hopefully, by the time I am 60 years old or within my lifetime, we'll get these pictures back and know whether there's life out there besides, life on Earth.